Now I'm going to make a little jump to one side and talk a little bit about cloud computing. Has anybody here used Amazon, for instance, or any dynamically configured server? Well, basically, obviously the word cloud these days is a bit of a hot word for whether you think that's right or wrong, but there are different aspects to the cloud as well. And the particular aspect I'm referring to here is the dynamic provisioning of servers. And Amazon, I think, is probably certainly the best known one out there at the moment, but there are a number of others. So Amazon Voxel Rackspace are what I call pure cloud platform providers. And then you've got things like Google App Engine, and Salesforce is effectively a cloud system as well. Obviously, it's rather more closed. So the general principle behind this type of cloud computing is that you rent servers as you need them, by the minute in some cases, in the case of Amazon, by the hour, or you can just leave them running permanently. Now you can configure these things remarkably precisely. So you can specify when you provision a server how much RAM you want, what type of processor, what hard disk storage you want. You can have offline storage that you can configure just like an ordinary hard disk. And you can also create machine images. So once you've configured your, in our case, your cluster, you can make a machine image of those, store them away, and then bring them back very, very quickly within a couple of minutes so that you're ready to run your, in our case, your data transformations. Another advantage they offer is they will offer server farms in different physical locations, so you can set up disaster recovery type procedures. And most of them come with content delivery networks, so you can deliver your content, your static content, very quickly. Other important features are auto-scaling. So for instance, you can set up your system that if a cluster of servers starts to, if the load increases above a certain level, it can automatically provision further servers and join them into the to the cluster or the server instance group. There's various monitoring features. Load balancing is a part of most of these systems, and you can also build custom scripts to deploy these things. So I've got here a sort of a good, simple but nice case study which shows an application put together by the Washington Post. They knew that, I think it was Hillary Clinton was going to release a whole lot of information, 20,000 pages of it. I'm not quite sure what it was about, but it was 20,000 pages of paper. And they needed to take that paper and convert it into electronic searchable database within a 24-hour news cycle. So before the whole stuff became old and passé, they had to get this processed. So basically, they set up a simple process where they scanned, did all of the formatting, cleaning, OCRing, and then when the actual data was released, they basically scanned directly into 200. They instantiated 200 Amazon servers, and they ran those for 9 hours. And at the end of 9 hours, all that data was basically fed directly into the database searchable format. And the total cost of that was $144. So I think that kind of illustrates the point very well, that if you have a situation where you have a lot of downtime and then suddenly a big burst of processing requirement, owning 200 servers would be out of the question. And in fact, as I'll show later on, as you reduce the number, you reduce it an awful long way. If you're going to be processing occasionally and predictably, being able to use something like this is a very, very cost-effective way of doing it. So I'll come to that slide in a moment. So now for how does CloverETL Cluster relate to that? Well, the cluster, obviously, the cluster product will often, normally, whatever, run on your in-house servers. But for the reasons I've just described, it makes a lot of sense often to be able to deploy those quickly for intense processing jobs into the cloud. So the demo that we're going to see at the moment actually shows the product working for real. And so what I'm going to do now, and I'm going to do my best not to press any wrong buttons because there's a lot of screens for me to move to now, is I'm actually myself going to try and fire up a cluster with 4 nodes in it, and then I'm going to execute a data transformation, first on my laptop, and then in the cloud, so we can see the speed difference. So let me go across to the back to my browser, and what I have here is the the Amazon management console. So let me go onto here and refresh that. Okay, so you can see this is basically the browser-based interface that Amazon supply that lets us view our servers, and I've got 2 of them running at the moment. So these are running. This one here runs a demonstration server that's constantly available through the Clover website. Now I'm going to go and actually fire up an extra node. So I've actually got 1 node here. This one actually is the what we call the master node, which we started up beforehand. So I'm going to go back to into here, and here's my cluster. If I just make sure that that's properly refreshed, I've got a cluster with just 1 node in it. Now I'm going to click on Start New Node, and this is set to automatically provision with Amazon a brand new server node, and that's done. Let me just go back here and let's start a 3rd one, and we'll do 1 more to give us 4 in total. There we are. Martin, I haven't messed up, have I? There we go. Right, I think I'm fine. If we go back to the Amazon console now and refresh, we can see that there are the 3 extra nodes that I started through my Clover GUI has triggered Amazon to instantiate 3 new instances. So the pending here means that it's in the process of provisioning that. So it's set up to in this case, provision a Linux server with a, I don't know, I think it's a quad-core processor and 8 gigs of RAM, and for that we would pay, I think it's probably about $1.20 an hour, so not very much money. The moment it says running, the clock starts running on me. Now, while it's doing that, it'll take a few minutes to actually provision those servers. What I'm going to do is to go back to Eclipse, to my designer, and I'm going to open up a graph. Actually, before I do that, let me actually run it on my laptop. In fact, I have that one here. So I'm going to start this running right now, because this will take a little while to run. So let me run it. So you can see here all of the numbers have been reset to 0, and it's now started reading in data. So in this graph, the first thing that it's doing is reading in data from a file that contains, I think, 6 million records, and it's about an 800 megabyte file. You can see it working its way through that. As it reads that in parallel, because it's a multi-threaded system, of course, in parallel it's performing a couple of calculations. So reading it in, passing it straight through the next component. It can't yet sort because it needs all the data before it's able to actually sort. In here, I can show you for instance, the calculation that's being done in that component. So it's actually taking our input data from this order file, so it's got a lot of line items, and I'm taking the quantity, and I'm just sending that out to my output structure, the quantity field, the price. Here I'm actually performing a calculation, so I'm calculating the discount, and here I'm passing the date, which I'm going to use for calculating the amount of time it actually took to ship the entire order further along in the graph. Now, this is one way of doing it. You can use simple drag and drop here through this screen, but Clover also offers, by the way, a very nice feature called CTL, which is a scripting language, and by doing that here, it's automatically generating this in the background. Now, if I want, I can use the CTL scripting to write little functions or complex functions which actually manipulate the data. So as each record is passed through here, this function is going to get hold of it, do something with it, and spit it out of the other side. So